Hello everyone, I hope you are doing good. Today I'm going to show you the bioconjugation. So here I'm making the carboxylic acid with a carrier protein. So this is called hapten, like a small drug molecule. If you can link a carboxylic group, then you can activate that carboxylic acid by using EDC. So it will form an unstable reactive O-acyl urea ester. And then you can use sulfur and hydroxysuccinamide, so it will kick out that EDC molecule from that unstable reactive O-acyl urea ester to make the semi-stable amine reactive and hydroxysuccinamide ester. So it is very active for the amine group. So when you use any carrier protein having lots of amine group, n number of amine group, so in the carrier protein, in all sides there are like an H2 group throughout the whole protein molecule. So here I am just showing one amine group with the n is a copy number, how many amine group is there, and depending on the free NH2 group, so your that activated semi-stable amine reactive NHS ester will react with that amine to form a new amide bond. So by this way, the number of that hapten carboxylic acid attached with this amine, then you can say that is a copy number. So this is the mechanism for this bioconjugation. Here the final bioconjugated molecule is this. Let's see how to do that part. So for the bioconjugation calculation, so our target is to make 8 milligram per 8 milliliter. We have to make a solution like 20 mg per ml. Okay, and from here we can take 400 microliter that will contain 8 milligram.
Okay.
Right?
Yes.
Because 1 milliliter, like 1000 microliter, will have 20 mg. 500 microliter will have 10 mg. So 400 microliter will have 8 mg.
Makes sense.
Okay?
Yeah.
So how we'll make this solution? So we will dissolve a certain amount. Suppose you have 10 milligram of the that carboxylic acid. Okay?
Yeah.
Carboxylic acid. So in that case you add 500 microliter of DMSO. And we are using this DMSO initially, and we are taking such way so that the final concentration of like this, the final concentration will have like around 5% DMSO in the solution. It is better like to have 5%, less than 5% or 5%.
Okay.
So according to our calculation, it will have 5% DMSO. So from this 500 microliter DMSO and 10 milligram solution, so it will be ultimately 20 mg per ml, right? If 500 microliter DMSO contain 10 milligram, so 1000 microliter should contain how much? 20 milligram. So the concentration will be 20 mg per ml, right?
Yeah, that's the starting.
Yeah,
Right.
that's the starting.
Yeah.
So even if you measure out something like 11 milligram, so how much DMSO you will use here to make it 20 mg per ml? Suppose you weight, take it in a vial, okay?
What was the
So
question?
you weight, like you take 11 milligram in vial. Now you want to make it 20 mg per ml solution. So how much DMSO you are going to use?
Wait, I thought we started out with 20 mg per ml.
No,
Wait.
like that's what I'm saying. Suppose you in a vial, you measured and you get like you need 10 mg, suppose, or 8 mg.
You want that much? Okay.
But you cannot measure like exactly 8 mg. Suppose you take 11 mg, but still you can make it like 20 mg per ml. So what you need to do, add 550 microliter of DMSO.
Okay.
Okay? So
Okay.
550 have 11,
Okay.
isn't it?
Wait, wouldn't it be 22?
In that case, it will be 1100, like 1.1 milliliter. Like 1100 microliter will be like 22.
Okay.
So just measure this. 1100 will have 22. 1 will have 22 by 1100. Okay? And 1000 microliter will have 22 into 1000, because 1000 means like 1 milliliter. Our target is per milliliter, right?
Yeah.
So 1000 over 1100. So 0, 0, 0, 0, 11 times 2. How much? 2 into 10, like 20, right? That milligram. So if we make 1122, then 1000 will contain 20, right? So ultimately concentration will be the same.
Okay.
So basically I'm trying to say, suppose in your vial sticky compound, you
Yeah.
measure like 13 milligram here.
Okay. Yeah.
But you need to make this solution. So what you will do, just half of that amount, like 13 milligram, that means 6.5. So you have to use 650 microliter DMSO. Does it make sense now?
Yeah.
Then
Oh wait,
if-
so this is the goal, the 20 mgs per mil.
20 mg per mil for the very beginning part.
Is the concentration that we want. So this is for later, the 8.
Yeah, that is for later.
Oh, okay, that's
Yeah.
why.
Okay.
Oh, and before you add any DMSO, is it already in DMSO?
No,
Oh, what is
this
it?
is your final, like that milligram will be your like compound.
To begin with, it's just
beginning
solid.
with the solid or like
Yeah.
sticky liquid.
And we're putting in
whatever,
DMSO.
Okay?
Yeah,
And
okay.
put it in the DMSO, dissolve it,
Cool.
and then from there, like whatever the solution you're taking, like if it is 13 milligram, make 650. If it is 11, then make 550. If it is 10, then use 500. If it is 9, then use 450.
Right, yeah. So,
Then
so
every
you
time
will
it
get
will
this
be 10
concentration.
milligram per milliliter, right?
Did you say 20 right now?
Yeah, it will be 10,
Yeah.
20, sorry.
Yeah. Okay.
So
okay, gotcha.
from whatever the solution you're making,
Yeah.
it will be 20 mg per ml. But from there, our target is to make 8 mg 8 per 8 ml. So we have to have the 8 milligram. So in that case, we will take 400 microliter solution, so that always 400 will have 8 milligram of the product.
Okay.
So
yeah. Wait,
if we take
my
400 microliters, so ultimately we will get 8 milligram.
okay. But my question is, why do we need this at all? Why can't we just directly go to this?
You cannot make like directly go to this, because if you take 400 microliter, you have to use solvent like EDC and and hydroxysulfonamide as NHS, that reagent, buffer solution. Everything will convert finally to the
Oh, this is the end result. So just
yeah.
and
End
that's
result
just
means like
5%
8
here.
mg means like 1 mg per 1 milliliter, right? Ultimately this one.
Yeah.
Our target is to make 1 mg per ml. So, but our real target is to have total 8 milliliter of the solution. So, if it is 1 mg per ml, so
Yeah.
total 8 milliliter means we will require 8 milligram.
Right.
Okay.
Yeah.
So in that case, we have to make the initial solution 20 mg per ml, so that we will take such way like so that we can have 8 mg. Now, if you want to make 10 milliliter per 10 mg per 10 milliliter, like 1 mg per milliliter, but you
Yeah.
need the volume 10 milliliter. In that case, you have to have 10 mg.
Then you need 10. Right. Yeah.
Then you have to take the 500 microliter to start with.
Okay.
Okay.
Yeah.
First, make the 20 mg solution, and then start with 500 mg.
Yeah.
Microliter.
Right.
You get it?
Yeah.
Okay. So in that case, here in a Eppendorf or any container, not glassware, glass container like Falcon tube or Eppendorf, take first add 20 equivalent of EDC. 20 equivalent in terms of your acid, carboxylic acid. Okay. Calculate that amount, 20 equivalent, and then add 20 equivalent of SNHS. Okay.
Okay.
And then
20 equivalent. Okay. Yeah.
and then not it is showing here. Actually
Oh
not
wait.
here.
It's gonna be a different.
Yeah.
It's gonna be plastic now, right?
Yeah,
Not-
plastic container.
Yeah,
So
yeah.
add those two first.
Yeah.
You add it solid, and then add water, 5200 microliter.
Oh, okay. Oh wait,
This
this
one.
is an empty container when before you add the EDC.
Yeah,
right?
and then add EDC and that anhydroxysulfonamide.
So
as NHS.
So the actual hapten is not in here.
Not here.
Okay,
So
gotcha.
then add
water.
5200 microliter of the water.
Oh, what kind of water are we putting?
Like definitely the pure water.
Mhm.
That should be like I normally used Optima brand water, pure water.
Oh, okay, cool.
The water used for the LCMs,
Sure. Yeah.
or like deionized water, very pure deionized water.
Okay.
So once you make this water, then immediately you can add that 400 microliter of your carboxylic acid. That add that. Carboxylic
yeah.
acid,
So you're
okay?
covering it. Yeah.
And 400 microliter means 20 mg per ml. That means I already explained you.
Right.
That 400 will have 8 milligram, right?
Yeah. Yes.
because if 1 milliliter contain 20 mg,
Oh,
like
yeah.
1000 microliter contain 20 mg, so
Right.
400 microliter will contain 8 mg.
Yeah. So
8 milligram.
before you add that hapten in, it's at 20 micro. So it's a milligram per milliliter.
Per
Yeah,
milliliter.
that's its current concentration. And
Yes.
Then, yeah, gotcha. Okay.
Yeah, so once it is added, then start rotation with the rotator.
Yeah.
We'll show how to do that.
Right.
And that will take a certain time for the activation, like total final of the N-sulfur succinamide.
Right.
And after 2 hours, then that's what he said. Attach the rotator instrument with the rotate, and it start rotating for 3 to 4 hours. Like normally for this one, which we are doing, that will be like 2 to 2.5 hours. Then each step is activating. This step activated.
Wait, what did you say? Ours is 2.5 hours?
Yeah, this is 2.5 hours. Like not 3 to.
Oh, okay.
Like or 3 hours is fine.
Oh,
Okay,
okay.
3
Sure.
hours is fine.
You can't overdo it, can you?
No.
Okay, so it's
In
safe
that
to
case,
go
it will be like hydrolyzed bag.
Oh, so
Just
yeah,
water
so it is bad
yeah.
if you keep going. Okay.
Yeah, do not keep back. Like
So
keep
3 hours
going.
max.
Yeah, 3 hours is max.
Okay.
And then then divide the solution. Like
Oh, okay.
so here you added the water 5200 microliter,
Yeah.
and you added 400 microliter of your acid solution. Total volume will be 5600, right?
Yes. Yeah.
So from there, actually our target is to make that CRM bioconjugated compound will be final volume will be 7000 microliter. That is
Okay.
7 milliliter. So
Yeah.
it will have 7 milligram,
Oh,
7
okay.
milligram per milliliter per 7 milliliter. You get
Yeah.
it? You get it?
The last bit was a lot of numbers, but I think I get it though.
So, like CRM conjugation we will need 7 milliliter.
Yeah.
So we're making our target is to make like milligram, right?
Yeah.
1 milligram per milliliter.
Yeah.
So since we need the 7 milliliter, how much the original acid should have in that
7 also.
7 milligram,
One,
right?
Yeah.
So that's why we are making
7,000 microliter.
7,000 microliter.
Okay.
So in that case, but since we are dealing with the 56, like 5200 microliter water and 400 microliter that's acid solution.
Yeah.
So total 56. Then that 56 will be divided into two, like 4900 microliter of this. Another is 700 microliter.
Okay.
So that 4900 will have 7 times 7, 49, right?
Yeah.
You can ask like why you are making,
Yeah, I don't know. Yeah. Why
because
is it-
our target was to make 7,000 microliter. Then we need to have 7 milligram.
Okay.
But original volume here is 56. So from the 56, oh here like total in 400 microliter total we have 8 milligram,
Yeah.
right?
Yes.
But now we want to divide in such a way so that we will have at least 7 milligram one part, another part will have 1 milligram.
That's why. Okay.
Yeah. So that's how we divide it here.
But why do we need? But we
So
we
it is
need
better.
More. We want more of the CRM.
Yes, CRM
That's what
we
we're
need,
using.
like that is we are using for the vaccination part.
Okay.
But
Oh, right.
and
Yeah.
always you have to have this from the same batch to compare to get
Oh,
the
it has to be
comparative
the same
result.
batch. You
Yes.
can- oh,
yes.
okay.
We already have this, but we will not use from the previous batch because you're dealing
making
you're
your own
making
now. Yeah.
So you have to use the same batch to be consistent with the result.
Okay, I gotcha.
So that's why we divided for 4900 microliter and 700 microliter.
Yeah,
So that's 4900 microliter will go for the CRM conjugation and 700 microliter will go for the BSA conjugation.
Yeah.
So that's 4900 microliter. Here now we are going to use the protein CRM that is also 20 mg per ml.
Okay. Yeah.
Okay.
Yeah.
And that will also need to be 1:1 ratio, right?
Oh my God. Yeah.
So how much we need there? Like now final volume will be 7 milliliter. So how much CRM we will need?
Oh, I don't know. The
1:1.
Yeah.
So this part will be finally 7 milliliter.
Maybe 7 milliliter. And it is,
So our original acid will be 7 milligram,
Yeah.
and that 7 milligram will need to react with the protein with how much? 1:1.
Yeah.
How much it requires?
7,
7
yes.
milligram, right?
Of the CRM. Yeah.
Of the CRM.
Yeah.
That's why since it has 20 milligram per ml, like
Yeah.
1000 microliter contain 20.
Yeah.
So to get 7 milligram, how much we need? 350 microliters.
Right. Yeah.
Right?
Yeah.
You get the math?
Oh, I get it. Yeah. Yeah.
Okay, so that's why we are using 350 microliter to get the 7 milligram of the CRM
Okay.
protein.
Yeah.
Okay,
So
now
the CRM is it comes in this.
Yes,
Yeah,
yes.
in this concentration.
Yes.
You didn't do that.
Yes.
Cool.
And then we have to adjust the all other like buffer solutions so that
When you add it
everything
up,
will be
it
like
adds up
yeah
to 7,000.
yeah 7,000 and
micrograms.
it will not change the concentration or buffer too much or anything. So that's why we are not using any water anymore, because we are using water in the beginning so that it will be reacting in the water. You can ask like, why didn't you add those buffer also in the beginning? We did that and that didn't give the good result. That's why we are
Result and
changed
copy number.
yeah, copy number.
Okay.
So that's why we change the procedure, like we will add
you
the
add the
buffer
PPS
later.
after.
Once it is activated, immediately
Cool.
once we add this, then we will add those things.
Sounds
Okay?
good. Okay.
So the that what is it called, like CRM protein, like carrier protein, and the 1400 microliter of the 5 pps and 350 microliter of 1 pps to make 7000. Now here is another point. Sometimes people get 10 mg per ml CRM. In that case, you will use 700 microliter, because 10 mg per
you
ml.
double it, right?
Yeah,
Yeah,
double
yeah.
it. Yes, 700 microliter in the solution. In that case, you don't need to add 351 pps anymore, because that will be double.
It accounts for it already.
Yeah, yes, and in that case, you will just add the 1400
And then you
microliter.
should still get
pps.
7.
Yeah, 7,000.
Yeah, okay, cool.
7,000 microliter means 7 milliliter. That means 7 milligram, 7 milliliter.
1 perfect.
1 1,
Okay.
right?
Yep.
And here the same thing, 700 microliter.
Oh, God.
And now you have to use, if you make 20 mg per ml BSA, so 50 microliter will have 1 milligram of the BSA.
Yeah.
So in that case, 700 plus 50 microliter BSA, and BSA will be dissolved in the 1 PBS, 1x PBS. Remember that, assume the CRM also will be in 1x PBS. Assume that.
Wait,
Okay.
in what, 1x?
1x PBS, like buffer 1 times, and this is 5x PBS, two different concentration we
okay.
use. Okay.
Yeah.
So the CRM is like taken that like it is in the 1x PBS.
Okay.
So here the 50 microliter and 700 microliter total will be 750. Okay.
Yeah.
So in that case, 50 more microliter will be 1x PBS. Then it will be like 800 microliter, and 200 microliter remaining will be 5x PBS, like polyphosphate buffer solution or something. Okay.
Yeah.
So that will continue, like total volume will be from here it will be 1000 microliter. That means 1 milliliter.
1 to 1, yeah.
So 1 milligram, 1 milliliter.
Yeah.
Okay.
Yes.
That will be the total calculation and total part. Now we are going to
Cool.
start, and we also can show the calculation part, how we are calculating.
Action.
Okay.
Okay.
So here the hapten means that carboxylic acid. We have the carboxylic acid that will be 1 equivalent, and our target is to make 8 milligrams. So based on that 8 milligram molecular mass millimole, so calculate the EDC part 20 equivalent.
Yep.
And then you will get this milligram.
Mhm.
And sulfur NHS that will be like 49 milligram. And for the BSA part also we can calculate 1 milligram. We will make it like, so you don't need to calculate like what exact. We will just make such
Okay.
a way so that it will be like 1 milligram.
Can I see your directions again? Wasn't there something that said 20 equivalents other than the EDC?
Oh yeah,
I swear there was
yeah,
two.
both will be like 20 equivalent. Yes, it will be also 20 equivalent. Yes.
Oh, okay. Wait, then do we have to recalculate that then?
Yeah, we'll double it.
Okay. Yeah.
Okay.
Sounds good.
So these are the calculation part. Now we are going to start, and before starting, what are the things we need? We need the hapten acid. Okay. In a vial, we measured, like if you see some solid here, so
Yeah.
yeah, the solid is there, and we will need this falcon tube. And
Oh.
it's better to have everything ready before starting.
Okay.
There. So we are taking 3 falcon tube, like bigger one.
Wait, are these all considered falcon tubes?
Yeah. So one I will label as pure water, like DI water, or like I'm going to use Optima water. So one
Okay.
is water, Another will be
So what does that say? Pure?
One.
Oh, it says pure water.
yeah 1x PBS.
And then ours 5x?
Another will be 5x PBS, like buffer solution. Okay.
Ooh.
PBS.
Yeah.
And we can calculate.
We just take how much we need, right?
How much
And dilute
total
it
we
to
need.
find,
Yeah. So here we will need actually 1400, and here it will need like 50 microliter and 350, like 400, 14 and 4, 1800. So if we have total 2 milliliter, that will be okay, but I will make 5 milliliter. So in that case, how we are going to do the change? So
It
from
usually
5 to
by a
1,
factor of 5.
yeah, factor of 5. So
Okay.
I will take 1 milliliter 5x PBS, and then I will add 4 milliliter of water. Okay, so
So I
it
get
will
5
be
mils
5
of
milliliter
1x.
of 1x PBS.
Yep.
Okay,
Yeah.
so let's first take the water with them.
Yep.
So here is the water. If you see like Optima.
Yeah.
So this is the.
Wait, where'd you get it? I just realized.
Yeah.
Wait, where was this?
This is under the
yellow.
desk. So Optima
Oh.
water. This water is very pure and like qualityful water. Normally, it is used for the LCMS, like like LCMS analysis. So we are taking
Used for
that
LCMS?
water
Okay.
and
Are we ever at any point just adding water in? No, right? I don't think
yeah,
so.
that's what I mean.
Oh, no, we are, yeah, at the beginning.
200 microliter. Right?
Gotcha. Yeah.
So that's why we are taking more water.
Yep.
Okay. Now first make the 1x PBS. So from 5x PBS, take 1.
Uh-huh.
So that is 1 liter. Okay.
Okay. Wait, 1 milliliter?
Sorry, yeah, 1 milliliter.
I was like, wait.
So
Alright.
we are transferring 1 milliliter.
Okay. Oh, 5x? Oh, yeah.
Yeah.
And then I'm gonna add 4 mils
Yeah.
of
So
water.
so 4 ml of the pure water.
And we want to be as precise as possible, right?
Yeah, definitely.
This is not
For the
some-
buffer solution, even if it is a little bit rough, it's fine because buffer the pH that's the target. pH will not be changed.
Yeah. See, if you have a little bit more, right?
Wait,
It's okay.
2,
Oh, yeah. 3 and 4.
4,
Done.
and you'll see roughly the total volume will be around 5. So
Yep.
if you do any mistake, like forget like how much I had, oh my god, I don't know. So just
You can't
shake
lose
it, makes it-
concentration.
yeah. So the what we are using here buffer like phosphate buffer because this buffer pH is like around 7.4, and our
Yep.
target is to keep the solution always at 7.4 buffer because biological systems
Biological.
need the buffer pH 7.4.
Yep.
You understand?
Yep.
Okay. Okay, now we have the water 5 PBS and 1x PBS ready. And now we are going to take or measure out the EDC and the NHS, that's
Right.
solid.
Oh my god. Yeah.
Yeah.
Yep.
So 20 equivalent both EDC and that sulfur.
Oh, so we adjusted it from
hydroxide.
the paper, right?
Yeah. So then we will start adding everything there.
Okay.
And in the
The cold, not the cold room.
biosafety
yeah.
hood, okay?
Yeah.
Because it is important to do the bioconjugation in the biosafety hood because otherwise if you do open or outside, your
Bacteria.
bioconjugate will be attacked by the bacteria or
And,
like
yeah.
other.
Yeah, that's why we're so concerned about wiping everything, right? When
Yes,
you put it in.
we
Okay.
have to clean up everything with the
Yeah.
alcohol mixture.
I'll fill. EDC is in the freezer.
Yeah, EDC always need to be in the freezer, so and treat anything. Yeah. So we are going to use these
Yeah.
and also just should have two of them. We
No.
are not sure.
What are we looking for? The sulfo NHS?
Yes. So this is N-hydroxysulfosuccinamide.
Yeah.
To make the solution little acidic. Okay. In that case.
Wait, isn't it already an acid to begin with?
Yeah, it was, but
Oh, to make sure it doesn't?
yeah, yesterday I checked the things.
Wait.
It is showing like kind of neutralish, but in acidic condition, it worked better.
How do you know
Okay?
how do you know it was neutralish? By pH paper?
Yeah, I
Oh,
checked the pH.
fuck.
Okay? So
I don't like using that.
let me delete some video from here. Previous video.
Wait, so we need for 9.8
Yeah, we
milligrams.
have 9.8 milligrams.
So we would theoretically need 490 microliters.
Yeah, 490
Of
microliter.
what? Water?
DMSO.
Oh, sorry, DMSO. Yeah.
Okay, so
But-
to make it 20 milligram per milliliter,
Right.
20 milligram per milliliter.
Yeah.
First initial solution, okay.
Yeah.
And from here we were going to use 400 microliter to take 8 milligram out of it.
Yeah.
Now, so we need 490 microliter
No,
DMSO,
DMSO.
but this solution also need to be acid adjusted, like pH adjusted, because ultimately we are going to use EDC and in water, and the sulfonamide, succinamide also in water.
You're saying under acidic conditions.
Acidic condition it works better.
Okay.
So before that, before making this solution, so and before adding it in the EDC and that solution, it will be like little acidic, like pH lower than the 7. So
Yeah.
that's why we need to adjust the pH here while we are adding the DMSO.
Yeah.
So that's why we are not using like total 490 microliter DMSO at a time.
Okay.
Initially, we will
Oh.
use like some amount, and then we will use 5 microliter, 10 microliter of 1 molar HCl solution.
Oh.
Then we'll check the pH, and once it is acidic, then we will volume top up the remaining.
Yeah, so we will not
parts.
actually be adding 490 microliters of DMSO. A little less
immediately.
than that.
Yeah, little less than that. Maybe like we can use 400 microliter.
Right. And the rest would be because of the...
Yeah, or
HCl.
like maybe 350 microliter,
Yeah.
and then adjust the acidity.
You
and
said
finally-
1 molar HCl solution.
Yes,
aqueous.
1 molar HCl
Okay,
aqueous solution.
cool.
Yes.
Damn, this is long.
Fractions over here.
Yep. Calculated that. Yeah.
It's better.
Wait, is it even gonna reach? Looks difficult too. Yeah. Okay.
But you need to learn, right?
Oh yeah. No, I'm more than happy to learn it.
And you will be doing like many things.
Like next year or later this year, I don't know. But I just gotta get this synthesis going.
Where I get the alcohol to? This
Right.
Okay. So okay,
So
now
what's happening right now?
we are making 2 milliliter solution. So here,
Of hydrochloric acid?
yeah.
Okay.
So here I'm adding the water, like pure
Just water. Yeah.
Yeah. And
Anytime there's water involved, it's optim.
and
Right?
very carefully just add in the wall.
So this is just diluting down the acid.
Yeah, diluting down.
Okay.
And I already added 166 microliter acid, so I'll subtract that. So 834 will be the next milliliter. You got it, right?
Yeah.
So first I added 1 milliliter, and now 834 microliter to make it total 2 milliliter volume to make it
Yeah.
1 molar solution.
Quick math. Ooh.
Okay. So, and everything, whatever you are doing, make sure that you label it. Otherwise, things can be
Right. Right here, underneath it.
here. 1 molar HCl. Okay.
Perfect.
Now,
And now we weigh out the other.
now I'll take the DMSO.
Okay.
Your DMSO will be here. One
Oh
is
my
the
goodness,
outside,
they're scattered
and
everywhere.
This is another DMSO.
Oh. Which one are we using?
6,
So,
8, and 21,
DMSO.
and this is looks like
It's so
here.
beautiful.
And there is another DMSO.
Oh my
so
god.
so
Doesn't
probably
matter.
we are going to use this one. This will be the better one, I guess.
The newest one? All right.
This is 99.5%.
Yeah.
So 99.5% Bio Ultra for molecular biology.
Sure.
Okay, so now we need 490 microliter, right?
Yeah.
So what we are going to take, first we will add
Oh, yeah.
around 350 microliter.
350.
Yeah, so here 350 microliter
Yeah.
of the DMSO we will add here.
Oh, like automatically, because it's a safe flow number, right? And then we add the acid
Yeah,
slowly.
so here
What is slowly, anyways? How much acid will we add at a
here
time?
in this
Yeah.
9.8 milligram hapten.
No, how much acid? Oh, no, like the HCl.
Oh,
Are we not going to be using up some of our compound? A little bit. A little bit.
That's why it is okay.
It's negligible. Is it? Like it's only a small amount.
Yeah, a small amount. That's why we are not using too much of like to check. So that's why before using like for this measurement, I originally use my original part where I take compound from there. That was when that was dissolved in methanol. I checked the pH, like how it is, or what it looks like. Is it basic or acidic?
Yeah.
So that looks like it is almost neutral in the pH paper.
Yeah.
So here, that's why we are using like very less amount, maybe like 5 to 10 microliter, or then we are going to use. So I'm just dissolving because that part was in the wall, so it will take a little bit time to dissolve.
Yeah.
Okay.
So you said the pH, you want it to be acidic a little bit below 7. How far low is too low?
Like pH 4.5 to 5 is fine, but you cannot measure exactly that. But the pH paper, you can see the like color. So if you see this color, I know. So
somewhere there.
Yeah, so somewhere is 5.
Okay.
So not greenish. Like if it is
5
like
and
this
7
color,
are literally the same.
Yeah.
To me.
To you,
They're
you're
very
colorblind. So okay. So I'm going to use maybe 10 microliter. It's 20, right? No. Yeah. So, but remember, keep in mind like how much we are using.
Sorry, what are we doing right now?
10 microliter acid.
Okay.
Yeah.
Oh, right. Oh, you just needed a smaller, what do you call that? Like a smaller scale? Micro pipette?
Smaller micropipette, yes.
Yeah.
So now,
I will not be making that mistake again.
when you are adding,
Yes.
try to dip in the liquid and then add, because it is very less amount, right?
Oh,
So,
and then it's just a one-time use,
Yeah.
right? Then you toss the needle, or sorry, not a tip.
in that case, since you dipped it and then shake it, and that pipette tip will contain some part in the top, right?
Yeah.
So in that case, use that one for the pH change.
Yeah, you might as well. Yeah. Okay.
You got it?
Yeah. And then if you want to add more acid later, then you have to use a different tip, right?
Yes.
Because you want to preserve your acid, I assume. Ooh.
So I can see that it is not changing directly, but
even-
still color is like little
I don't know if it's
greenish, not like
it's kinda
red.
green, red, orange.
Okay, so I'm gonna use another
I
one.
hate PHP.
Yeah, I know.
Except when I
So
want
I'm
something to be
going to
basic.
use-
If I need to be basic, it's fine.
10 more microliter
Yeah.
again inside this liquid, and
It's
I'll
better
do it.
to release it in the liquid, you said?
Yeah,
rather
yeah,
than just on
yeah.
top.
So now I'm going to use this part.
By the way, if you were to vortex this, would it like damage everything? Is that why you need to do the slow rotation?
Yeah, that is like during the bioconjugation, but now the vortex is not like problematic. Okay.
Oh, later on when it's already activated. That's
Yeah.
what. Okay.
So I'll take a little bit here.
Remember, this is supposed to be green.
Not green.
Oh, this is not green. You said it was green.
It will be like little pinkish.
Oh no, but is the paper itself green? Yeah, I don't know. I'll just take your word for it every time. Ooh, what is this? Looks green to me.
Not green yet.
Oh no, yellow. Oh wait. Oh, okay. Whatever color that is.
Yeah. So, but still, it is not.
Is that not
pinkish or red? That is like pinkish.
Wait,
not this one,
what
this
is
one.
what is? Oh,
This one.
what is 5? What color is 5?
What do you see?
I see orange. Is it not orange?
No, it's
oh, it's. Wait, is 7 orange?
7 is kind of greenish yellow.
And 5 is.
5 is not
red.
greenish. 5 is, I don't know, not deep red, like
Somewhat red.
somewhat red.
And then 3 is red.
Yeah.
And 1 is dark red. Okay.
So I'm using third time.
Okay. Damn. Look at them. The hair on that arm. Does it usually take a few times?
Yeah.
Because you don't want to overdo it. Okay, maybe can you put it down? Let me see if that works. There we go.
Yeah.
What
so
am I
looks
looking
like
at?
color is getting changed.
It's supposed to be what, 5-ish?
5, yes.
Yeah. Enough. Looks enough the same to me.
Yeah, so I think like not 5 exactly, but it is getting changed. Like if you see the color here, like 7, we don't want 7. It should be like acidic mode. So
Yeah.
it looks like close
It's
to
enough.
5 enough. So
I think it's enough.
yeah, so we are not adding any more acid. We added 30 microliter.
So whatever the
One
difference
more
is,
acid,
we
yes.
add more of the thing, the DMSO.
Yeah, so here
Oh my god.
stock solution 50 microliter DMSO here.
Right.
Okay?
Yeah.
So if we take
Total
400,
volume, yeah.
if we take 400,
Yeah.
so we need 400 microliter DMSO. But right now, how much we added DMSO? 350 plus
However much you just add now, right?
110,
Yeah.
460.
Mm-hmm.
Right?
Because you added 10 microliters of
Yes.
the acid.
Yes.
Yeah, yeah.
So 460, right?
Everything total together. Oh yeah, 460. Yeah.
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 So 9.8 contain 460, 1 contain how much? So 460 divided 9.8, 46 times 8, 375.5. Okay.
But isn't the acid solution already in there too? So why are you calculating with 46 and not the 49?
What?
The HCl is already in there too. So why are we even using the 460 microliters at all? Shouldn't we just be using the total 490 because they're all together now?
Yeah, that's what I'm saying. So
Yeah.
ultimately that solution will go to the water and we are adding HCl with the water.
Yeah.
So that water we can reduce there, but we need to have the 5% of DMSO. So the
Oh, okay.
required DMSO should be there.
Okay.
You get it? Okay. So here, we need 490 microliter of the DMSO, but to adjust the acidity with the HCl, we added 30 microliter of the HCl solution.
Oh no,
in
you're
water.
saying the 490 was in the calculation already?
In the
That's
calculation,
to
yeah.
get the 5% DMSO.
to get the 5% DMSO.
Oh my god. Okay.
Yeah, you have to keep those things in
Oh.
mind. Like you have to be very subtle for
Yeah,
calculation.
yeah. Okay.
So since we added 30 microliter of that HCl solution, like in water,
Yeah.
but we are using now 460 microliter of DMSO. So in that case, I will add total 490 microliter DMSO, like remaining 30.
Regardless, yeah.
But additional, how much water will be there because
30
of the ACL?
microliters more, right?
30 for the 490. But
Yeah.
we are going to use 400 microliter.
My God, so you have
for
to calculate.
400, how much?
It's a
we
ratio.
have the ratio.
Yeah, yeah.
Yeah, so I
So you
calculated
calculate
it will be 24.48 microliter of the water. So in that case,
Okay.
when we are using this 5200 microliter of the water, so we will use less water there.
Oh my God. Okay.
You got it?
Yeah.
So here, I will use 30 more microliter. That means 140 microliter.
So if you make one mistake, all your numbers are off.
Yeah. So 145 microliter. So the total volume will be this plus 30 microliter. Okay.
Yeah.
So in 400 microliter, it will have. Okay, with the 30 microliter of the acid solution and 490 microliter of the DMSO, the total volume will be 520 microliter. So we can calculate. Originally, we take 9.8 milligram the solid or the compound. So 9.8 milligram contain 520 microliter. 8 milligram will contain, like you can find out this. It will be 424.48 microliter. That means 424.5 microliter. Like 424.48 microliter. If you take this, then it will have total 8 milligram. And in that case, because we are adjusting this with the due to the acid HCl solution in the water. So in that case, we will use here not 5200 microliter. It will be just remove the 24.48 microliter from this 52. So 52 minus 24.48. So it will be 5175.52 microliter.
Action.
So I adjusted.
Okay.
So our total volume, like we are using 490 microliter DMSO and 30 microliter HCl solution. Total volume will be 520 microliter, right? And that original amount is 9.8 milligrams. So 9.8 milligram contain 520 microliter. So 8 milligram will contain how much? So 424.5 microliter. So we are going to take 424.48 microliter here. Like here means like to add there. Okay. So here,
Okay.
So here it will be 424.48 microliter. Like we can take 24.5 microliter.
Yeah.
You understand?
Yeah.
So that's the change is happening. So we have to. That's what I'm saying. Like we have to adjust the remaining DMSO. So what is the DMSO we added? So we added all of this already. Like I added 110 also, but here I did like 140.
Yeah.
So 30 more microliter like I have to add. You got it?
Yeah.
Like the amount of the acid we added, that much less we didn't add here. So here I'm going to adjust. That is 20. Now 10. Did you understand the part? What I am doing exactly?
You just readjusted, right? To ensure that it'll still be 5% DMSO in the end.
Yes.
Yeah. Actually, what are you doing at the moment? Like right now? Like, that's the DMSO. Okay.
Yeah. So basically, how much DMS we need to add? 490.
Total was 490. Yeah.
490, right?
Yeah.
But since we have added 30 microliter of the HCl,
30 microliters HCl. Yeah.
So initially I thought like 30 microliter HCl and 460 microliter of the DMS, so that will be 490 microliter of the volume, right?
Yeah.
But then originally DMSO is decreasing here, right?
It will be less than 5%.
Yes.
But, yeah.
So that's why the required amount of the DMSO we need to add. And since the water, ultimately in one of the first step, we are using water and HCl is going to water.
Yeah.
So that water can be adjusted in that phase.
Right. Yeah. So
Right?
you'll just add less water later.
Less
on.
water later. And that's why we can add that 490 plus that additional water, like 30 microliter. The total volume is going to get 520 microliter, right? That has 30 microliter water.
Yeah, and then later on we'll
Now-
do 20 microliter less.
Now I just calculated. Okay, so
Yeah.
total volume will be like 520 microliter. That is 9.8 milligram.
Okay.
So 9.8 milligram
Right.
in 520. 8 milligram will be in what?
In
volume?
that
So that's what I
424.
get, like 424.5 microliter.
Okay.
But originally for our calculation to
Before
get 8
that.
milligram, how much we needed? 400 microliter,
Oh,
right?
So now we need more. Yeah.
Now we are needing like 24.48 microliter more.
because we added more liquid.
Yes,
Yeah, we had water.
right?
Yeah.
So ultimately the same. The
It's the same,
CMS
yeah,
will
yeah.
be the same, 400 microliter.
Yeah.
But that additional part will be water,
Right.
and that's why we are adjusting that water there.
Yeah. So did you grab the 424.5 yet?
No, not
Not
yet.
yet. Okay. Oh wait.
So we are making this solution.
Oh, yeah, and then now after this we're gonna make the sulfur
we are,
NHS.
yeah, we will going to measure those amount.
Yeah.
Okay.
Yep.
And then we'll go to the biosafety.
Yeah. Okay. All right. Gotcha.
Okay. Mostly the complicated part is done, like those adjusting
That's
the
what
solvent
they
and
all
solution.
say.
Okay.
Okay.
So now we are going to measure the solvent,
Yes.
solid part.
Yeah.
And we'll take this in the Falcon tube and add the liquid according to the adjusted calculation, and then the things will happen.
Do solids just make everything easier in chemistry?
Yeah.
It feels like
yes.
it.
Yes, the solid feel makes everything easier. So we need EDC as 86.68 milligram. It's better to measure the other one first because EDC shouldn't be keep open quick for a long time. So measure this one first. So what I'm measuring, sulfur NHS. Okay,
Yep.
and that should be 99 milligram.
I'll just keep recording. Should I be?
As you wish, but so I'm measuring just 99 milligram, 20 equivalent of our acid.
Okay. And the other solid is EDC, also 20. So they're both 20 equivalents.
Yeah. Okay. It is
Is that?
100. So you don't need to
Is that
be
fine?
like exactly that amount because since we are using 20 equivalent, that means
It's a
way
lot
more
already,
than-
yeah.
right? So in that case,
Just don't overdo it. Don't
yeah,
do like
a
50
lot,
equivalents.
Like 50 equivalent, yeah. So if it is like 1 or 0.5 milligram excess, it's fine because those are like common sense, you know.
It's already in excess, yeah.
Yeah, it's already in excess. So now I'm taking
Classic.
the solid here.
And yes, this is a Falcon tube.
Yeah.
So they're both Falcon tubes, the thin and the thick one.
Yes.
Okay.
So now I'm going to measure the required EDC part here. And use another one. How much EDC we need? 86.68. Sushi.
No, not seriously. This is like dried fish. That's just what. Wait, what's giving that smell? Is it the nitrogen?
I mean,
Don't amide. Yeah, amines always have that scent to them. Not always. What is this? 99. Oh wait, no, 01. No, it is it. Okay.
Are you ready?
So this is a new one.
So
Zooming. All right.
this is the biosafety hood.
Yeah.
Here we will use our bioconjugation part, reaction, everything mixed up.
Yep.
But before doing that,
What?
before doing that, we need to sterilize this part with the ethanol solution.
Yeah.
So that's why I bring some paper towels. Before putting those things, I will
Everything, if it goes in,
there
it's
goes inside.
Including your gloves.
Yeah, like not gloves. Actually, gloves are new things, so that's okay. So because not to get contamination of the bacteria or any other thing. So before using, take some ethanol, 70% ethanol in your gloves. Okay.
But what else is in here? Water?
Yeah, the rest of the part will be water. And now,
Oh, they mark the water for you. Cool.
take these.
Yep. Do the usual.
Yeah, as
Remember
usual.
that.
And then open this one, insert it, turn on the light.
My God, it needs to be extra clean, right?
Yeah.
Oh, and you especially need gloves in there, right? You don't want your own, your skin
No,
and your cells.
Okay. Now I'm gonna do also this, but make sure that you are not erasing your labels so
Yeah.
that in that case will be. Still
Oh dear, those two.
yeah, normally there are some sterile always keep people like those things, but here and it worked.
Yep.
You're pretty there. And we have to
And
do.
now it's just now it's the additions, right?
Yeah, so now we have taken those two solid here.
They're
Okay.
combined, just both solids together.
Yeah, so we'll take 175.52 microliter of the water. So
In the two solids. Wait, by the way, we don't even have the protein at all here, right?
no,
There is no CRM, there is no BSA yet. That is
no. So now we're using the water.
Yeah.
One,
This is into the solids, the
Two.
sulfo
yes,
and the ETC. They're in there together.
3, 4, 5. So 5,000. Okay. Now 175.
More microliters. Okay.
Yeah.
Oh, such precision here.
You can take 175 76, it's okay.
Wait, what? A little extra?
Like 0.5 extra. Okay, so water is done. And what we can do, just to mix it.
So was this your new calculated amount of water?
Yes.
The reduced amount?
Yes.
Okay.
And now we are going to add 424.5 microliter
Of the hapten
yes
solution. So hapten solution goes into.
actually we can add 400 with these and 24
With that.
404 actually we can add 404 here and okay so
424.
yeah 25 actually anyway. So
So keep going sideways. Here we go.
so that is 400
Yeah, you go back and forth a little bit. Right?
yeah
Just so nice to see it live too in person. But then I have to look at the camera. Okay.
so make tighter and then do this way.
Yeah.
So this process is called activation process, so now it will start activation.
Is that it? And now we just attach that?
Yeah, we'll attach it.
Oh wait, what about the... Oh wait, the PBS is already in there.
No, we didn't add
No, it's not.
the previous yet.
Wait, what?
So now just
Let it spin.
let it spin.
Right?
And one thing you can do,
Yeah.
it looks like it may touch there, so
Yeah.
now it will be going on for 2.2 hour to 2.5 hours to activate. And once it is activated, then we will use our carrier protein CRM and the remaining 1x PBS and 5x PBS solutions.
So we're gonna have two different tubes in the end, right? Because we're splitting them.
Yes.
Some will be BSA, some
Yes.
will be Okay. And we're doing them simultaneously, parallel.
Yes.
Okay.
So
Oh,
one thing we can do,
Yeah.
we can leave those things here,
Yeah.
okay? Because in that case we don't need to do like clean up again.
Yeah. Well, my question is here. Didn't it say you were adding the PBS earlier on? Oh no, you scribbled it out. Yeah. Okay. So PBS is later. It's not now.
Yeah.
Gotcha. Okay.
Do you know why? Do you know why we are not using PBS now?
I don't know if this is the exact reason, but we did want this to be slightly acidic, right? And then later on, you want it at biological pH, which is why you want to buffer it.
That's correct.
Yeah.
So that activation required in water only, but if you use the 1x PBS or 5x PBS, that will continue the pH like 7.4.
The point is to lock it there, right?
Yeah, that's why we made the acidic, right? By using
to activate. Yeah.
by using HCl, 1 molar HCl to lower down the pH.
Yeah.
So that's the issue, like we are not using that. Otherwise we could use all those solutions together and then finally we could just separate 1 milliliter for the BSA and 7 milliliter for the remaining part. You got it?
Yeah. So the PBS will take care of the acid later on. We don't have to neutralize the HCl at all right now. So, okay, so once the buffer is in, it'll stay at 7.4.
So now this process is going like activation.
Yep.
So let it be done.
Yep. 2.5 hours, you said?
Yeah.
It's 240 right now, approximately. So, is there a specific speed? Can you even make this faster or slower? The rotation speed?
I don't know.
Yeah, is this fine? The way it is?
This fine. This fine.
Wait, what's the reasoning and why do we need it like this? Like specifically rotating and slowly?
Like mixing, reacting, but if we do like two first, so in that
centrifuge,
case,
it's too
yeah, it will be
violent.
violent.
Okay.
And especially when you add protein,
Yeah.
then the protein will be precipitated out.
Okay.
So that's
Cool.
a reason.
Cool.
So now we are going to separate these two parts,
Yeah.
4900 and 700 from the original what we did.
Yeah.
So 14900 will be used for the CRM. We know how much CRM we have to take and other solutions, so we will add that.
Yeah.
And but from here 700 we have to use 50 microliter of 200 milligram per milliliter BSA. So you have to make a solution, like measure the
Yeah.
certain amount of the BSA.
Yep.
And suppose you have taken 10 milligram in a vial. So if you add 500 microliter, then it will be 20 milligram per ml, right?
Wait, did you say 10 milligrams?
Yeah, if you say 10 milligram and add 500 microliter solution.
Oh, when you 10 milligrams, it's dry.
Yeah.
Oh, BSA is
Yeah.
solid, right? Oh,
Yeah, base
okay.
is solid. So
Okay.
and if you add 500 microliter
Yeah,
of
yeah,
water, so it will be how much? 20 milligram per
10
ml,
milligrams.
right?
Yeah.
But while you are measuring BSA as a solid, suppose you come up with 11 milligram.
Oh,
Okay.
shit again. Yeah.
So you have to add 550 microliter of the water.
Right. Yeah.
Not water, actually. You will use
TM.
1x PBS to dissolve.
Oh,
that.
well, we have enough 1x. Right. We already diluted earlier.
Yes.
We had a lot. Yeah. Enough. Yeah.
Yeah.
Okay.
So
Wait, are we doing 5 microliters of 5x? Oh, okay. Yeah. That was
Yeah.
calculated already.
but since we need here around some part
Yep.
1x PBS, we made 5 milliliter, right?
Yeah.
So I think that will be enough.
Yeah.
Yeah.
Yep.